Hello, this is the review for exam 1. If you have completed your homeworks and your projects, the exam 1 is going to be very easy. It's going to be basically the same type of questions that you get for your homework, and it's going to be 4 questions. So let's go ahead and review the main things that we need to know for the exam. So we started by talking about electric charge. And electric charge is fundamentally the exchange of electrons between atoms, but we won't get up to that level. We care about the flow of charge because the flow of charge in time is what is called the electric current. So for example, find the charge, the units are coulombs. So that's one thing that we have to remember. The units of charge is coulombs. Let's find the charge that requires 200 microjoules of energy to be moved through a potential difference of 20 millivolts. So remember, the potential is another way of saying voltage. And that's why voltage has minus, plus, because it's a potential. So to find the charge that requires 200 microjoules of energy to move through a potential of 20 millivolts, the only thing that we have to do is apply the formula that tells us that charge, Q, times voltage is equal to our energy. So this is Q, this is voltage, this is energy. If we want to know what is the charge, the amount of charge, then we simply have to do energy divided by the potential. In that case, it's 200 microjoules divided by 20 millivolts. So, as you know by now, the equations that you have to use in this class are extremely simple, are linear relationships, and they're just multiplying a few things. I've noticed that the complication, most students get confused with the prefix. So I've noticed in some homeworks, and this is probably the part that you have to pay more attention than even the calculations of the formulas, because the formulas you can always find. This exam is going to be open book, open notes. So you get the exam and you solve it, you send it to me. So it's very important that you know the prefix. 200 microjoules is equal to 200. Let's open something else here. So 200 microjoules means that's 200 times 10 to the negative 6 joules. Micro is 10 to the negative 6. This part is micro. Divided by 20 millivolts. 20 times 10 to the negative 3 volts. So it's not simply 200 divided by 20, because the prefix is not the same. It's 200 times 10 to the negative 6 divided by 20 times 10 to the negative 3. This is equal to 200 times, parenthesis, 10 to the negative 6 divided by, parenthesis, 20 times 10 to the negative 3. This is the same as 1 over 100. So 10 millicoulombs. This is the same thing as 0.00, sorry, it's not 1 over 1,000, it's 1 over 100. 1 coulomb. So 10 millicoulombs is 0.010 C coulomb. Okay, so 10 millicoulombs is the same as 0.01 coulomb. You can express as when you get from your calculator like this, or you can simply say, well, this is 10 millicoulombs. Every way that you express this is the same, so this is okay. Next is how much charge passes through a radio battery of 9 volts. The potential is 9 volts. If the energy expended is 620 millijoules. So this is not mega joules. Mega is capital M, and that is a lot of energy. That is mega joules for power in electricity and plants. So capital M is mega, which means 10 to the 6, and lowercase m is milli, which is 10 to the negative 3. So careful with the prefix. It's the same thing. If they're asking about charge and they give us the potential and the power, is exactly the same formula. So in this case, it would be 600. What is going on here? 600 and what is going on here? 620 millijoules times 10 times 10 to the negative 3 divided by 9 volts. And for 450, how do I get this in .068? So 68.9 millicoulombs. So 0.068889 coulombs is the same as 68.889 millicoulombs. So again, you choose how to express it. If you don't want to get confused with this, just simply write this and add the units. So very important, the units for your answer. That is a very important part. And when you get your units, you'll know if you're doing something right or wrong. So don't forget the units. Next question or example. Will a fuse rated at 1 amp blow if 86 coulombs pass through it in 1.2 minutes? So it's very simple. Really, the complicated part here is knowing that 1.2 minutes, you have to turn that into seconds. And to turn that into seconds, simply 1 minute is 60 seconds. So you multiply 1.2 times 60. And if you remember, current is equal Q over T. Charge divided by time. So you simply say 86 divided by 1.2 times 60, everything in the denominator. So this part is okay because you have coulombs, you have seconds. So you just 86 divided by 1.2 times 60. You don't have to worry about any prefix here. And the answer is 1.194 amps. So since the current is larger than 1 amp, then yes, the fuse will blow. So the next thing that we saw was Ohm's law, which is the basic, the fundamental building block of circuits for series and parallel. So to apply Ohm's law, you basically have to know or have information about your voltage, your current, and your resistance. So remember, for circuits in series, the current is the same throughout the whole circuit. And to find the current, you find the total resistance. So to start applying Ohm's law, let's see the example that we have here. What is the voltage across a 220 ohm resistor notice that it's not kilo ohm or mega ohm, it's just 220 ohm. If the current through it is 5.6 milliamps, so this is the part that you have to be careful. Milliamps is 5.6 times 10 to the negative 3 amps. So we have 5 points. Let's do this in the calculator. what's going on? 5.6 5 5 woof 5.6 5.6 times 10 to the negative 3 is 5.6 milliamps times 220. Times 220, enter, 1.23 volts. So this is correct. Next one. If 540 joules of energy, again, another thing to remember is that energy, the units are joules, power, and units are watts. So joules over second are watts, or watts are joules over second. So if you have energy divided by time, that will give you power. So if 540 joules of energy are absorbed by a resistor in 3.6 minutes, another common example, the problem here is that if the problem requires seconds, because power in watts is defined as joules over second, not joules over minute. So be careful here. Notice if they're asking you for watts, you have to turn this into seconds. What is the power delivered to the resistor in watts? Okay, so that was easy to know that they were going to ask watts. Really, the important thing here is to change this into seconds. It's very simple. So following the formula, we know that 540 joules divided by the time in seconds, and 3.6 minutes in seconds is basically 3.6 times 60, because 1 minute is 60 seconds. So that will be 540 joules divided by 216 is 2.5 watts. Okay, very simple. Another example. How long can you use an Xbox 360 nonetheless, for $1 if it uses 187 watts and the cost is 12 cents per kilowatt hour? So again, be careful with the power that it uses is in watts, and what they are charging you at the end of the month is in kilowatts. So it's very simple. If you have $1 to spend on your Xbox or TV or whatever, if you have certain amount of budget for the energy that you're using, the way you do this is $1 will give you 8.33 kilowatts hour if they're charging you 12 cents per kilowatt hour. Now 8.33 kilowatt hours divided by 187 watts. So notice that this is 8.33 kilowatt hour divided by 187 watts. Therefore, to turn watts into kilowatts, you divide by 1,000. So this divided by 1,000. Divide by 1,000. So it's this divided by 1,000. and this will give you 8.33 8.33 kilowatts divided by 0.187, 44.54. So that is 44.54 hours, right? Because your kilowatts and your kilowatts are canceled, therefore your answer is in hours. So $1 can give you 44.55 hours of entertainment. So for example, how would you know why 187 watts? Well, very easy, because so for instance, this is not part of the problem, but it's another question that you could get, not for this exam, because Xbox is not a DC circuit. It is a DC circuit inside the board, but when you plug in through the wall, this is AC, so it's 120 volts AC, and it's telling you that the current is such that you can get a power of 187 watts. Remember, the volts and current give you power, but the problem is that this is RMS, so don't let me confuse you. I just wanted to let you know that you could know what is the amperage draw by your system based on the information that they give you. So at that point, if this current is too high, we saw before that if it's higher than 200 milliamps, is pretty dangerous. So if this current is in amps or even 500 milliamps, anything larger than 200 milliamps, then this could be dangerous for your own safety. So the way to operate with circuits is that you have everything unplugged, your voltage is unplugged, and you are very careful that when you're switching components or you're working on a component, your circuit is not functioning. There's no power going through it, or there's no current flowing through the elements. Okay? So another thing that we saw was the circuit in series, and this is really the part that all the concepts that we were learning were leading us to, because pretty much almost anybody could do a V equals IR and tell you that what's the current or the voltage or the resistance of an element. But really the important thing is knowing the concept of circuits, because circuits are the building blocks of systems and controls and mechanical and electrical engineering and physics. Circuits really are the building block of any scientific and engineering application nowadays. So, of course, those circuits are series and parallel, but for now we're learning the series. After exam 1, we're going to learn parallel. So make sure that you understand the concepts for series, so that when we learn the concept for parallel circuits, you can combine both of them. So for instance, find the resistance, the total resistance, given the, find this resistance. Find the resistance R given that the multimeter or ohm meter is reading 129 kilo ohms. So since it's reading 129 from here to here, the values that are being read are this one, this one, this one, and this one, because this one is not part of the circuit in series. The circuit in series is this circuit. Okay, so when you measure the voltage, the resistance here, the total resistance of this circuit is measured 129 kilo ohms. This part right here is not being measured, because notice that this is open to a different, something different. It's not connected to the circuit. In fact, this is open. There's no current flowing through this. So what is the resistance R? Well, this is very simple. It's telling us that 129 kilo ohms is equal to R1 or R plus 56 plus 22 plus 33. Okay, so it's one equation, one unknown. Therefore, this is going to be simple. Is 56 plus 22. This gives you 78. And then 78 plus 33 will give you 111. So 129 minus 111 equals R. And this is in kilo ohms. And this is 18 kilo ohms, right? They're actually giving you 18 here to confuse you, I'm guessing. It's interesting, but this one is not counted. It's just this. So R is equal to 18 kilo ohm. Okay, this is the total resistance. With the total resistance, you can find your current, I, if they give you a voltage potential. But right now, this is just open. There's no current. There's no voltage. They're simply measuring the resistance of the circuit. What about this one? Let's do B. So 103 kilo ohms kilo ohms are equal to 24 plus R1 plus 43 plus R2, which is 2R1. Excellent. So one equation, one unknown, which is R1. So this is equal to 103 is equal to 24 and 43 gives you 67 plus 3R1. Very well. And then we know that we have to subtract this from 103. So let's go up here and say 103 minus 67. This divided by 3 will give you R1. So 103 go ahead and do this. One oh three minus 67 divided by 3. Enter. Missing parentheses. Oh, I see why. Because this is parentheses. Enter. 12. Very well. So R1 equals 12. R1 equals 12. And R2 equals 12 times 2, 24. So 24 plus 24 is 48. And 48 plus 12 is 60. And 60 and 43 is 103. So this checks. Good. So that's how you do the total resistance of this example. Another example. For the configuration in figure 597, which is this figure, constructed of standard values, A, find the total resistance. So by now we know how to do that. Is R1 plus R2 plus R3, and they have the same prefix, so it's 10 ohms plus 12 ohms plus 18 ohms equals 40 ohms. So even if they don't ask you what is the total resistance, you're probably going to have to find it anyways, because that's how you get to find your current, which is the same everywhere. The current in a circuit in series is the same everywhere. So that's good. We have a total resistance, then calculate the current. Well, they're basically walking through how to use Ohm's law. So 72 divided by your total resistance is 1.8 amps. Find the voltage across each resistor. Okay, so in that case, we have to use the current we just found, 1.8, times the resistance of each element. So V equals IR. So 1.8 times 10 is 18 volts. For element 2 is 1.8 times 12 is 21.6. And 1.8 times 18 is 32.4. So if you add all those three voltages together, you should have the same thing as your source. In practice, ideally, when you build this in the lab, it's maybe not going to be the case, because you're gonna have some loss of electrons because of soldering, or because the wire is too long, or because you're not using the same gauge wire. So in practice, you can have some inaccuracies, but these three voltages together should give you the source voltage, right? And D, calculate the power by the source. So we know P equals V times I. We know the I, which is the same everywhere, 1.8. We know the V is 72, therefore is 129.6 watts. And find the power for R3. They're only asking for one particular resistor, so it's because they're only interested in this one. Maybe this is a sensor, or this is really the important part of this circuit, but they're only asking about this power right here. So for that, we also know the current, and we know this voltage drop. So it's 32.4 times 1.8 is 58.32 watts. So this example is very useful, because this is, if you understand this example, you'll have no issues for the exam. Now, KVL, or Kirchhoff's voltage law, is something else that we saw. And the KVL law is another tool to characterize or analyze DC circuits. And it's very useful because by applying the voltage law, the KVL, you can find the voltage or currents or resistance, or the resistance at a specific point in your circuit. So I recommend you study the first one, A. Study this, because this will explain very well. This will help you understand very well the KVL concept for the exam. So let's go ahead and solve 2, for instance. So using KVL, find the unknown voltages. So that means that we have to find V1 and V2. You notice that V2 is from this point to this point. But this point is not connected to ground. That's the interesting thing. So to find the V1, we find the KVL law. Is very important to know the direction of your power source. So from minus to plus, if that's the direction, we take that as a positive. From positive to negative, we take that as a negative. Okay? So 10, positive 10, minus V1, plus 6, minus 2, minus 3, equals 0. Remember the summation of your voltages, VI, every voltage should be equal 0 because of the conservation of voltage. So you have only V1 as the unknown, therefore one equation, one unknown, V1 equals 11 volts. And V2, now V2 is the voltage between this point and that point. So for that, we only need to study this part of the circuit. Okay, or this part of the circuit. Because if we know everything else, then we can know what is the voltage between 2 points. And in that particular case is minus to plus is positive 10, plus to negative is negative, so negative V2, and plus to negative, so negative V3 equals 0. Therefore, V2 is equal to 7. Voltage dividers and series. So the question is, determine the value of the unknown resistors in figure 5.115 using the provided voltage levels. So this is basically using the voltage divider rule. So we know that R1 is 2 ohms, and we know the voltage at each element. Therefore, we know that the proportion of 1 volt over 2 ohms is the same as 50 volts over R2. So to find R2 is 50 times 2 ohms divided by 1, is 100 ohms. Therefore, this is 100 ohms. For R3, you can say, since we have 1 volt and 2 ohms at V1, we can do the same thing and do 100 divided by R3. And those give you 100 times 2 divided 1 is 200. Okay, so there you have it. Similarly, if you were to do from 2 to 3, saying 50 divided by R2, which we found R2 to be 100, is equal to 100 divided by R3. Okay, so 50 divided by 100 is 1/2. So 1/2 equals 100 divided by R3. Therefore, R3 goes to multiply and 2 multiplies there. So R3 equals 2 times 100, which is 200. So you can do any relationship, V1 to V2, V1 to V3, or V2 to V3. As long as you know the voltage and the resistance, you can do the voltage divider rule by doing the relationship between voltage and resistor. And this is because notice that V divided by R is current, so that these two things are related to themselves by the current, which is the same for the circuit in series. So again, you can do V1 to V2 or V1 to V3, or you can do V1 to V3, V2 to V3, depending on what information you have. And the last one, for the configuration shown with standard resistors by inspection. So a standard resistors meaning that is not a potentiometer or some non-linear resistor. It's just a regular linear resistor. So by inspection, which resistor will receive the largest share of voltage? So be careful here because there are different magnitudes. This is 100 ohms, this is 1 kilo ohm, and this is 10 kilo ohms. So 10 kilo ohms plus 100 ohm plus 1 kilo ohm. Therefore, if we do that, it's going to be for A, which will receive the largest voltage. So we're going to do 100 plus 1000, which is 1 kilo ohm, plus 10 kilo ohms, which is 10,000. So this is 11,100 ohms. Okay, that's the total resistance. And since the voltage was 60, then we can find the current by saying 60 whoops 60 divided by 11,100. So approximating that is 0.0054. So basically it's 5 milliamps. So the current through this circuit is 5 milliamps. I equals 5 milliamps. Therefore, if you do V equals IR, which is Ohm's law, so 5 milliamps times 0.005 times the first resistor, which is 100, we get 0.5 volts. Okay. Now the second resistor was 1000, 1 kilo ohm, gives you 5 volts. And the third resistor, which is 10 kilo ohms or 10,000 ohms, gives us 50 volts. Okay, so notice that by inspection, which is not what we did, we actually went ahead and did the whole calculation. By inspection, you know that R3 or V3 is the largest because has the largest resistance. So A is the answer to which resistor will receive the largest share of voltage. Why? Because it's the largest resistance. Therefore, the voltage drop is the highest. B, how much larger will V3 be compared to V2 and V1? Well, simply you can do the same thing that we did before. It's just the relationship between V3 to V1 and V3 to V2. So V3 to V1 means 10 kilo ohms divided by 1 kilo ohm is 10 to 1 or 10. And the relationship between V3 and V1 is 10 kilo ohms to 100, which is also, if you get rid of the zeros here, 2 zeros is going to be, this is 10,000 and this is 100, so it's 100 to 1. So the relationship between V1, V2, and V3 is V1, V2, and V3 is that V3 is 100 times larger than V1 and 10 times larger than V2, which is what we did here. This is 10 times larger than V2 and 100 times larger than V1 because it's 0.5. Find the voltage across the largest resistor using the voltage divider rule. Very well. So you know that the voltage divider rule, as we said before, is V3 divided by R3 is equal to the voltage of the whole thing, which is 60, divided by the total resistance. So that basically means 60 divided by our total resistance, which we computed as 11,100. So that gives us, let's do it here. So it's 10 kilo ohms, 10,000 times 60, and we're going to do divided by the total resistance, which is 11,100, and approximate that 50.405. So the voltage in C, the voltage across the largest resistor, finding the voltage using the voltage divider rule, is 54.05. In D, find the voltage across the series combination of R2 and R3. So it's the same thing as we did, but it's going to be R2 plus R3, which is 11 kilo ohms or 11,000 ohms times 60 divided by the total resistance. So that is going to be R2 plus R3. So R2 was 1 kilo ohm or 1,000 plus R3, which was 10 kilo ohms or 10,000. So this is 11,000 times base supply, which is 60 volts, divided by the total resistance, which is 11,100. That gives us 59.45 volts.